Good afternoon, team. So, welcome back to our ImageGrafix webinar. Today, we'll be seeing the latest enhancements happened in Caesar 2. So, basically, this will be our agenda. What are the code updates we had, and what are the new features and enhancements we had in Caesar 2? So, what are the code updates we are having in the latest release of Caesar 2, whether it's V14, which is in the market? So, basically the 31.12, the code which has been long pending for many customers requirements has been included in 2000 V14 of Caesar with standard for analysis for hydrogen piping and pipelines catered into. Following to that, the 31.1 2022 edition power piping code has been updated with 31.3 2022 edition of process piping has been updated along with 31.4 2022 edition pipeline transportation systems has been updated to the latest release, and 31.5 is also been updated to 2022 edition, and 31.8 also been updated to 2022 edition, and your EN 13480 also has been appended with your 2022 edition. So what exactly has been implemented in 31.12 and how is the code different from the existing piping codes which are already available in Caesar? What makes this code more important? So 31.12 code is comprised with three parts. One is your general requirements which apply for both your industrial piping as well as your pipelines, and industrial piping part and your pipelines part. So IP applies to the hydrogen pipings in gaseous and liquid hydrogen services. PL applies to the hydrogen transmission pipelines, distribution pipelines, and service lines used for transporting hydrogen from a production facility to the point of final use in gaseous hydrogen service. So these are the two codes which are being included in Caesar, and Caesar has a separate code for as 31.12 IP, which is for industrial piping 2019 edition, and similarly 31.12 IPL 2019 edition, which is for your pipelines. So what does each indicates? So when I go with 31.12 IP, what it is, industrial piping offer refers to your 31.3. So when I see my window on the screen, I'll be able to very much clearly indicate that the window simply resembles my regular 31.3 piping window. So what makes it different from 31.3? In IP, allowable auxiliary dialog box in Caesar 2 contains matching inputs from 31.3, including new requirements for material performance factor and your coefficient. So these are the two parameters which are an additional requirements in 31.12 compared to 31.3. So what are those? The display and input provides a default value for the factor MF, that is your material performance factor, according to 31.12 table 9.5, and the coefficient Y is assigned a minimum value of 0.4 by default, with any other value requiring manual specifications. So by default value for Y is 0.4. Any other value, it has to be specified by the user. And so these are the two things. Next, the most important thing is in the recent trends of 31.1 and 31.3 code updates includes the updated flexibility factors and SIFs for your inline components like T's, bends, reducers. So what does the 31.12 refer to? By default, the software still uses the flexibilities and SIFs from Appendix D of 31.3 2018. Optionally, 31.31J for SIFs and flexibility could be applied through configuration settings. So the last line item, optionally 31.31J SIFs and flexibilities, is an process to be applied by default, not by default, by in consultant with your end customer who is the actual decision makers and everything. So that's one thing which you have to be very careful with. But by default, the software always uses 31.3 2018 edition Appendix D only. Then we have your pipelines. So now when I speak about pipelines, there is a new terminology change which happens to be here. If you look out, you have SU, T1, T2, T3, and SC, SH1, SH2, and F1. So this is a new thing which comes into picture whenever I have these pipelines selected. Now what this? PL often refers to the 31.8 gas transmission and distribution piping system piping code. The PL part of the code distinguishes between the restrained and unrestrained piping in stress calculations using the HF material factor and F design factor. So the allowable dialog for PL includes 3 columns of acceptable inputs to adapt to the requirements of stress equations. So now the default expansion allowable for PL code uses SC and SH for unrestrained piping as interrupted from para PL 2.6.7 for IP calculations. Optionally, the user can request to use the 31.8 section 833.8 interpretation for expansion allowables, which clearly states it is 0.33 times your ultimate tensile stress, SUT we say. So how do I activate it? When I check this box, the expansion stress allowables automatically changes from 31.8 request to your 0.33 SUT, ultimate tensile strength. This is going to happen by the software once we enter our data, and once I check this box, automatically the software takes care of that. And similarly, similar to your 31.12 IP system, the software still follows the flexibilities and SAFs in accordance with your Appendix E of 31.8 2018 edition. Because PL 31.12 PL part refers to your 31.8 code. Hence, the SIFs and the flexibility factors would be referring your 31 Appendix E of 31.8 2018 edition. And the user has the freedom of using 31J flexibilities and SIFs if necessary. So moving further, to satisfy the 31.12, definitely the standard materials from 31.3 may not be directly be users. So there are some 119 material records being updated by software in the software. The thermal expansion and elastic modulus are from Appendix C of 31.3 2018 as defined under section 31.12 IP 6.1.4, and allowable stresses are taken from 31.12 table 9.1a. Other physical properties are from ASME boiler and pressure vessel code BPVC section 2 part D. So the same has been referred in the properties for flexibility factors IP 6.1.4. So what has to be taken? The thermal expansion coefficient, values of thermal displacement to be used determining the total displacement shall be determined from Appendix C of ASME B31.3. So that's what this code has been referring to. So by default, the thermal expansion and elastic modulus would be referring 31.3 2018. Okay. So moving further, 31.1 2022 edition. There are some 4 material database updated in 2022 edition of 31.1 material database course. So that has been updated in Caesar 2. And in 2022 edition, the axial index IA is now applied to the entire longitudinal stress term, not just your axial force term as in 2020 edition. So if you can see the code equations, we can very much see the IA has been applied to for both PD by 4T plus F by A. Previously, it was applied only for F by A alone. So that is a major update. So which results in slight variations of our expansion stress range results compared to the lower version of Caesar 2 results and the latest versions of Caesar 2 results because of the formula changes in the code equations itself. And enable the configuration setting SIF multiplier for sustained stress index for use of B31J. So this is the SIF multiplier for sustained stress index. Here you will have some drop down details which indicates what to use, how the SSIs are calculated by the software through SIFs. So that can be done. So what is this? What updates have been provided or what are the options I have? We'll see it in our due course of presentation. Then there has been some major updation in 31.3 also, which consists of 2 parts, 31.3 main body and chapter 9 for your high pressure piping. Requires the use of 31J starting from 2022 edition, so that's mandatory. The graphs and tabular values for both the basic MDMT values and reductions have been updated in 2022 edition. Material properties from tables A and K have been modified in Caesar to material database editor. This update affects a total of 25 material records. So there are some updations happened in the table A and table K of the code book itself, which refers our metal properties. By default, Caesar refers those tables. So there are 25 material records been updated to match the updated edition updates. Although the overall stress equation remain unchanged, the calculations of the F stress range factor from the number of cycle is modified. So what are those modifications? We'll see it. So more on the stress range factor. The stress range factor F curve slope was changed from 5:1 to 3:1 based on ASME pressure PVP paper public paper as 61871. This work proves that 3:1 figure curve slope is more accurate than the previous 5:1 slope. So in reality, this was the original formula for F in 2020 edition of our ASME B31.3 code, which has been remodified as this one in 2022 edition of ASME B31.3 code. The new ASME B31.3 formula shows lower F for a specific N value, indicating more stringent requirement of cyclic services. So that makes me the stringent. I'll be in more conservative mode whenever I'm performing my cyclic stress calculations on my with my software. This results in less allowable displacement stress values compared to your 31.3 2020 edition. So we have a more reliable and more conservative mode of analysis. Stress results, more stringent requirements has been updated by the code itself. So that also has been implemented in the software. Then let's see about the 31.4 2020 editions, 2022 editions. So what are the major updates? 2029 edition includes edition 2019 and 2022 for a total of 6 code options. Now from 2022 edition for 31.4 also the B31J has been mandated by the code. So analysis with ASME B31J safes and flexibilities are used by default for edition 2022, and B31J may be used optionally if you are following the 2019 edition of the code. A maximum stress range factor of 1.2 can be used to compute the expansion allowables, and that can be set at the bottom. Per requirement, for as far as I said, the applicable temperature range is limited to piping with design temperature between -20°F, that is 30°C, to 250°F, that is 120°C. And error checking warning is issued if outside of this range. So whenever I'm going for 31.4, this is our range as per the code. So if I'm having anything falling outside this range code, then there is a warning under the error check module. For restrained pipes, the expansion allowable is updated to use the minimum of 2/3 of the specified minimum yield strength and 1/3 of the specified minimum tensile strength SU. Prior to 2022 edition, it was only 2/3 of your SY was used. Are used in all calculations and do not vary with temperature. So that's what has been explained in your right hand side from the codebook. The snippets taken from your codebook. And there are 10 new API material records have been added for the 2022 edition in Caesar2 material database. Then related and other enhancements, transportation offshore piping codes define more than one candidate code stress with corresponding allowables. The software now features an enhanced algorithm for static analysis, accurately combining individual code stresses before selecting the governing stress value. For dynamic analysis, it has been updated to handle all three candidate code stresses and their corresponding allowable stresses. And this is mostly for your cross-country transportation and everything. So this applies for both 31.4 and 31.8 code. When I speak about 31.5 2022 edition, there has been no major updates in the code edition itself. And Caesar2 has just implemented the updated code release, making it mandate, as this is made mandate by many of the code requirements. Flexibilities and SAFs from 31.5 table 519.3.6. The use of a B31J is not mandated, but as a user, the software supports the user to use 31J if and when required or recommended for your project and company requirements. Similarly, 31.8, we don't have much updations compared to 31 compared in 31.8 in the latest releases. Have been added into the piping code list along with the same editions containing 6 codes. And here also the 31J is not mandated, yes. So still it uses the appendix E of your 31.8 code book for your flexibilities and SAF factors. And as I was already mentioning, if required, the user has the freedom of using the 31J flexibilities and SAFs when and where required. And even by 31 even 13480 also does not have major updates as compared to your lower versions. So the code release has been amendment has been performed. So that is what is included in Caesar. Same entry in piping code list is used with only the piping code label changing as A5 2022 or from A4 2021. So the extended legacy report has been slightly modified for single SIF implementation of EN13480 to reflect the same value in both in-plane and out-plane SIF fields when user specified values is used. So there are these are some of our analysis codes, pipe stress analysis codes. But apart from there are some other codes are also been used in Caesar which are also been updated. One among them is our API 617, the equipment and building code updates, which has been improved to implement the 9th edition, that is released April 2022 has been implemented. ASC 7 2022 edition has been implemented for design load calcs associated criteria for bending structures. International Building Code 2021 edition has been updated. So these are the three major codes. So what are those details individually? No major inclusions of the 16.617 API 617. The analysis report is just updated from API 617 to satisfy the 9th edition requirements. One of the notable updations or the future enhancements with respect to API 617 was the software, the allowable load multiplier. Whenever the user is providing the allowable load multiplier greater than 2, the software was by default resetting the value to 1 and performing the analysis. So that has been updated in the latest version, latest edition. So if the allowable load multiplier is specified with a value greater than 2, warning will be displayed, and with that value only the software is going to evaluate our stress calculations being performed. Okay. So then ASA 7 seismic horizontal force equation for non-structural components has been changed. Side factors FA and FB has been eliminated. Spectral response equations parameters shall be obtained from USGS seismic design geodatabase. So under your earthquake spectra, we have your AAC 7 2022 edition, seismic wizard, and AAC 7 2022 edition. So these are the three areas where I have the AAC 7 to be utilized. So this has been updated to 2022 edition. The wind directional factor KD has been moved from velocity pressure equation in AAC 716 edition to the design wind force equation in AAC 7 2022 edition. So the velocity, so these are some of the updations in with respect to your AAC 7. The change, however, does not impact the resulting design wind force itself. Then the IBC 2022 edition. So similar to what we have seen in our API 6 or ASC 7, we have so the same thing has been implemented for your IBC also with the option of selecting multiple design codes, even in our DLF or dynamic load case analysis also. So apart from the code updates, what are the other future enhancements for the users to be utilized? We'll see about it. So the ISO 14692, there's no much updates as the code requirements, but the ring bending and roping stresses. So these are some of the requirements coming from various users using ISO 14692. What is that? Calculate ring bending and roping stress for all stress categories. However, table 1 of the standard shows that they should only be estimated for operating cases. Now the Caesar 2 14 has provided some enhancements to address this issue, that is, set the ring bending stress to 0 for algebraic cases with 0 pressure. Set the roping stress to 0 for any algebraic cases regardless of the pressure values. So these are some provided enhancements which has been implemented, and based on that the ring bending and roping stresses are evaluated. The allowable envelope is available only for certain load cases, but expansion and fat report stresses displays 0 instead of blanks. Hoop and longitudinal code stress as applicable. There is a new clarification note in the error checker to aid the user to understand the analysis as such here. So what is roping stress and what is your ring bending stresses, the details and how it is being evaluated, what is the integration. So that is been provided in our error check module itself. Reports accurate stress analysis for FRP piping systems compliant with ISO standard. So further applications of board-on effects to FRP pipes. CZ 214 enhanced the ISO 14692 for both 2005 and 2017 editions. So related to the propagation of envelope input values, reporting of governing code stresses when the envelope is not defined, handling of load cycles in calculations of occasional allowables in dynamic harmonic analysis, eliminate the allowables to be being set to 0, updated the stress reports to display maximum between hoop and axial code stresses. In the previous versions, only hoop stress value was displayed when allowable envelope was undefined. So further improved the internal logic to automatically apply the board-on effects for FRP pipes in calculation of limiting force for the restrained pipe status. Now next, B31JS and SIF. SIF multiplier for sustained stress index is now utilized when B31J is enabled, either for B31J piping codes or when user selects the use B31J for other piping codes. Previously, this setting was ignored when B31J was enabled, and now allows the SIF to set to 0.75 SIF, which is applicable for most piping codes. This is how in the latest version, the user has the option of default. So whenever the configuration SIF multiplier setting is 0, B31J method as calculated by B31J for your 31.3, 31.1, everything 0.75 times of your I, and with 31.3 such as JPI and 31.5 we have I is equals to SSF, SSI is equals to SIF. Now there are some other values. So for multiplier as 0.001, your sustained stress index would be equals 1 for all cases. And if I set my SIF multiplier as 0.75, my for B31J method itself, it will be applicable for 0.75 times SIF and in most of the cases. And if I set it as 1, the SSI and SIF will be equal for all the calculations. Now this default value will be always 0. That is the default settings by the software, which makes the SIF value and the SSI values are varying in accordance with your code requirements. So there was some animation and elemental viewer error happening in time history analysis in the lower versions of Caesar, which was identified and been modified. So the dynamic animation feature specific to time history, element viewer, the red tracker, and the contents of the saved results to the text file. So associated with the improvement work implemented, multiple defects were resolved. So when they were working for this, there were multiple defects coming across, and almost all the defects were resolved. Like the Dynaflow plot file now includes the combination displacement on rigids. Animation elemental viewer in time history matches the results. Units reflect correctly as specified on the configuration file. Time history animation event viewer works in non-English units and other units. So this is how it will be working. So whenever I was playing and when I was looking for the element viewer, whatever the results been shown here, when I check with my actual outputs, results were completely differing. So that was some graphical issue within the software that has been updated in the V14 version. So there has been a new hanger table manufacturers pipe support been included. That is your Relco manufacturing hanger table data has been included. And for your annual hanger tables, the fifth and working range has been included. That is your spring sizes for 000 and 00 for the B268 springs have been also included. And similarly, the fourth and fifth size range for your PSSI groups hanger tables are also been included. So improved the global coordinates of disconnected segments when performing editing operations such as renumber, delete, invert, and undo. The global coordinates of disconnected segments are preserved and not reset to the origin 000. So whenever you are deleting our element, we find most challenging task is the element after the deleted element would go and sit at 000, and again I need to relocate it, all those stuff. So now it will be present in the same location. When I delete a mid element, the end element's global coordinates will be taken as a reference, and the element would be segment would be staying in the same location. I would say this has been benefited many users. Why? In the sense, whenever we were performing flange checks using NC3658.3 method, the yield strength of the flange material at design temperature, the user was forced to enter the values from SY, SY1, SY2 through SY9. Now in the latest version, how many corresponding temperature, the values for that corresponding temperature, if your SY, SY1, SY2 has been provided, the remaining values can be left blank. So that is one major update happened in V14. Then we have the increased the internal limit of this included structural jobs from 20 to 200, added an error message when 200 maximum count is exceeded to avoid crashing of the software. Added a technical discuss for thermal bowing in Caesar 2 user guides. Piping codes that use B31J can now use the SIF multiplier for a sustained stress index option in the configuration editor also. From PCF import, whether you are using your regular PCF or APCF, improved and fixed several issues, including improve the consistency of handling the mapped supports NS or EW, and the north direction of global Y and Z up, handling negative node numbers, eliminating duplicated elements, and processing non-English restraint tags has also been updated in the latest release. So enabled sustained stress index. So we have already seen that is 0.75 times of your SIF using configuration settings. Static stress reports for our primary stress types such as sustained, occasional, or hydro now display the sustained stress intensification, that is SSI, for metallic piping codes. Now there is a PDF report viewer in the output viewer wizard. Previously, whenever I want to generate your PDF report, I have to have a PDF driver installed, and one by one, stage by stage, I could be able to generate the PDF, not in a single click. Now I have a combined PDF report viewer in my output viewer wizard, static output processor alone. Added a new version of offline help for installation that do not require internet access for online help. Offline help now opens in your default web browser, and of course it remains compatible with Windows 10 and 11. So that comes to the end of my session. So thank you for your time, and thank you for your attending the webinar session.